Hi guys, welcome to the channel Code by Raghav, and in this video we are going to solve the LeetCode question number 74, that is search a 2D matrix. It's a medium type question and it has been asked in many interviews. So as you can see, it has been appear in many big companies interviews like Microsoft, Adobe, Uber, Google, Public Sapient, HSBC, Salesforce, these are the big names right there. So let's read the statement and see how we can solve this question. And so we have given an m cross n integer matrix, not the 2D array, not the 1D array. We are given a 2D array. Each row is sorted in non-decreasing order, and we have given each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. So as you can see, these are the sorted 1, 3, 5, 7, 10, 11, 16, 20. Given an integer target, we have given an integer target. Return true if target is in matrix or false otherwise. And you must write a solution in O of log of m cross n time complexity. If you closely see which approach is best to solve this question within this time complexity, is the only one approach, that is binary search. You can use two more approaches also. So let me remove this. The first approach is basic brute force approach. You run a nested for loops and visit each cell in the matrix and find your target. That's the brute force approach. And the second approach is using the two pointers, like place I there, J there, and you compare the last element with your target. This last cell element of the row with your target. If it is greater than, means the element will be in the next row. If it is smaller than, your target is smaller than, means it is in the same row. We just have to decrease the j. If it is greater than the target, this last cell, means you have to increment your I. So that's the second approach. So both approach, the brute force and this approach, will be solved in O of m cross n. So now we move forward to the binary search approach. What we do in the binary search approach, let's say we write this element in the linear fashion in the 1D array, like 1, 3, 5, 7, 10, 11, 16, 20, 23, 30. Let's say this much. So we take a low starting from the index 0, we take a high and we calculate mid. Suppose this is the mid, and we check if the target is, if mid is greater than the target, then we move our high. If mid is smaller than the target, we move this L. So that's the binary approach. But in the 2D matrix, it's kind of complicated, because so let's first apply the binary search in this. So where we So the first we calculate the number of rows. The number of rows will be 3. These are the rows 1, 2, 3, and the number of columns will be denoted by n, that is this one, 1, 2, 3, 4. Number of columns will be 4. Now we take a low pointer that will initialize by 0, and we take a high pointer, it is initialized by 0, and we point a high pointer which should be initialized by m into n minus 1, that is the 11th index. It's a 0 based indexing, that's why we are subtracting minus 1. Now we try to find the mid. So what mid we get? 0 plus 11, it should be 5. So we get mid 5. Now what's the 5? How? By using this mid 5, we got the mid 5. How you can find which cell is on the index 5? It's a 2D matrix, it's not a 1D matrix. You can search like nums or matrix of mid. So you have to know the proper row and the column. So how you can find the row and the column? By using this mid. So how would you compare? Is, let's say this is our mid. How would you compare it is bigger than the target or lesser than the target, or if it is equal than the target? We have to know where our mid is standing, which cell is at our mid is standing. To calculate the row and the column, we calculate the row by dividing by n, that's a hack, and we calculate the column by modulo of n. So that's how we calculate the row and the column. We find row by dividing the mid by n, the number of columns, and we find the columns, cell column, by mid modulo of n, that is column number of columns, that is 4. So what we get? 5 mod division by 4, that is 1. And let me write the indexing: 0 1 2 3, 0 1 2, and we get column 5 modulo by 4, that will be 1. So the column will also be the 4. Then we compare the cell that we have calculated from this mid. Is it equal to the target? In the current question, yes, it is equal to the target. Our question is finished. We will return the true if it is equal to the target. Let's say our target is, let's say this is 16 is our target. Now we got this as a mid, this 11 as the mid. Now we compare this mid cell. Is it less than the target? Means we have to update our low. So what will we do? Low is equal to mid plus 1. That's our default binary search. If it is 11 is bigger than the target, let's say our value is bigger than the target, then we move our high pointer, mid minus 1. So that's it. That's the basic binary search approach. The main important point is how you can calculate the row and the column. That is the important point. Then rest of the code is default binary search template. So let's solve it fast. First we calculate the number of rows, that will be the matrix dot size. Then we calculate the number of columns, matrix of first row dot size. Then we take two pointers. Low will initialized by 0, high will initialized by m cross n minus 1, and while low is less equal to high, now we calculate the mid. Low plus high minus low by 2, int value. What value are we comparing? The matrix of the how we can get the row by dividing the number of columns, and how we get the column by modulo with number of columns. Now we check our default conditions. If value is equal to the target, return true. If value is less than the target, move our low pointer, else value will be greater than the target, move our high pointer, and if we haven't found any targets, return false. Let's try to pass the example test cases. The test cases, let's try to submit it. Our solution has been accepted. Time complexity will be O of log of m cross n, and the space complexity, we are not using any extra space, O of 1. So that's it for the video. Thank you for watching. Make sure you like, share and subscribe. Thank you.